Hello, everyone. Good morning. Or actually, it's afternoon today. Oops, I don't need this. I'm in my own house. I don't need a mask. Hope everyone's doing all right today. Today, as you can see, we'll be doing a little bit of hacking on ZMK. This is going to be a little weird because this tripod sucks, and every time I touch the table, it bounces, so... it may take a little adjustment. Sorry for the shakiness that will come today, but I will work on a better breadboarding situation. I thought about just doing it over at my normal spot, soldering spot, and moving the monitor and stuff like that, but it's kind of an ordeal. So I was like, okay, whatever, I'll just do it this way. So we'll see. As you can see here, maybe, got a Raspberry Pi Pico. This is actually not what I'm going to be using to do this. This is what I hope to get to the point where I can do, but I'm going to do a nice Nano first. But this is a, what is this? This is the Xiao from, I don't even remember. Xiao controller. cduino Xiao. I think that's how you pronounce it. Xiao. It's a little little controller that like the I don't remember what keyboard it is. There's a keyboard that uses it. It looks like a butterfly. I think it might even be called the butterfly. I don't know. But it's just a little microcontroller. It's like $5 instead of 25, so it's cheaper to burn than like a nice Nano, but it doesn't have Bluetooth or anything, so I think it's probably good for a development board, which is what I'm going to use it for. But today, not even going to use this either. I'm going to go straight up nice Nano. I think I've got one ready to go here. I don't know. But the main goal of today is to get a nice Nano on a breadboard with a switch that I can press and it makes a keystroke. That's all I really want to do. If I get that done, perfect. If I get more than that done, that's just icing on the cake. Over the weekend, I did go about setting up a build environment for ZMK. I figured out, well, I don't want to say I figured out. With Pete's help, I figured out why I couldn't build the Zephod locally, and it's because I was using the wrong branch of ZMK. Because apparently his is a fork and with the branch, and it just needs to get merged in. And since the Zephod is not a production board as of yet, it's fine that it's a branch or whatever. But I did manage to get it working, and in fact, this is using that firmware that I built. So that's awesome. Mainly I wanted to do that just to verify that I had it all working and like not have to go, okay, let me try to get this working. It doesn't work. Let me go ask for help and then kind of sit here because there's nothing else to do until then. So I got the build environment working. Now it's a matter of rapidly iterate on getting everything else working. So yeah, so first thing first, I'm going to get my nice Nano out. Hummingbird, that's it. Yeah, it's a really cool looking board. I am going to show Windows at some point. Like, not capital W Windows, because I don't use Windows. But, like, documentation I'm reading and stuff like that. But we'll see. It also depends on how much people want to see what's going on the breadboard versus what's going on in the code, and it's just going to be some experimentation today. And yeah, sorry, this sucks. I don't like that. I need to get a better mount for this spot. I also need to get a better mount for the normal spot because the tape that was holding it to the board, for some reason, it's just not doing it anymore. So I need to figure something else out. So it might just be that I use the same stand at both places and I just move the camera. But we'll see. At the very least, we have a keyboard today. And you might also be wondering why I'm using the Zephyr wired. And that's primarily because I've had lots of issues with Bluetooth keyboards in macOS. I don't know why. Works perfectly fine wired. I don't care. I'm going to use it wired. It's fine. But I do have a wireless trackball, so that's also kind of fun. And yeah, you might see this here. This is my new Touch ID Apple keyboard. It is cursed, but it has Touch ID. Works really well for the Touch ID part, so I'm going to try to, at some point, rip that apart and see if I can't get the Touch ID module out of it without destroying it. I have a feeling I'm going to destroy it. It's going to be $150 down the drain. I'm going to feel a little sad, but it's all in the name of science, right? Anyways, let me get out a nice Nano, and we'll start cracking on this. Well, I thought I had a nice Nano all soldered up with headers, but I guess not. So we're gonna solder one together real fast. Yeah, I don't think ZMK works yet on the 2040. I got a bunch of 2040s, or I got a bunch of the Pi Picos just to play around with. But I want to do this in ZMK. Like I was gonna, and I might still figure out how to get MicroPython or CircuitPython or whatever running on here, reading from this. I was gonna use that as a, like, well, at least I know I can deal with Python. Like, I don't know Python, but I'm better at Python than I am at C, which is saying a lot, because I suck at Python. But, like, I figured this would be nice for, like, I don't know what the hell is going on. It might be easier to read from this, better tooling, I don't know. So we'll see. But I'm going to solder this nice Nano up real quick. And I say real quick, but I don't even have the soldering iron on. I got this finished the other day. My artsy board. Now I have a bit more mess on my desk again, but oops. Yeah, this thing is just too springy. Like, I'm just touching the top of the camera and it's springing around. I don't like that stand. hacking on the Zephyr bits for this, for the touchpads. Okay, iron is heated up. I'm actually going to flip the 9.0 over because this has labels on the pins, and that should be helpful. And sorry I'm not soldering on camera. The camera I would normally use for soldering is the one that's right here. So but I will be back in just a moment. Okay. Since I'm probably not going to use the shell just yet, I'm going to pop this off. that in the controller box. Oh, I still haven't figured out links. Sorry. Post them in the Discord or DM each other or something like that, please. Sorry. I don't know what's going on with those. I don't know if maybe it's like I have to get to 1,000 subscribers and then I can mod it. I can change that, or I don't know. YouTube confuses me sometimes. So something frustrating that happened, or that is part of this and why this is such a mess, is I bought one of these little headers. Okay, let me take several steps back. So this is the touchpad, the actual trackpad itself. You connect it using this ribbon cable. Okay, great. So I've got a ribbon cable adapter here, except the only one I could find for 12 pin has 2 parallel rows of pins, and they're right next to each other. So you can't stick it right in a breadboard because you need a little gap in there. Okay, that's fine, because they make adapters. So this little adapter here has 2 rows of parallel pins, and it's spread out. The problem with this is you pop it in the breadboard, and it just boop, pops right out. It doesn't stay in there at all. So it's kind of useless. So I had some of these header extenders or extension cords or whatever. I don't remember what they were called. And I'm using those, but they're just fugly because, yeah. But it's fine. It'll get the job done, hopefully. So I'm gonna put these over here. Yeah, I don't think it's the breadboard, because I have 2 different breadboards. I tried this breadboard, and that didn't work either. I think it's that the legs on the little adapter aren't long enough that they stick in, and so they just pop right out. And of course, when I went looking for, like, has anybody else had this problem, or is there something I need to do? Someone's like, don't use a breadboard. I'm like, thanks. That's useful advice. Thanks. I'd not use a breadboard. They're like, breadboards suck because they're bad physically and bad. Come on, dude. Like, whatever. It's just frustrating. Okay, so this doesn't have any firmware on it or anything, or yeah, it doesn't because it's blank. This is a V2 Nano. I probably should put a little label on it so that I know it's a V2. Oops. V2. Wow, that is... Alright. Okay. Next up. Okay, I want a little adapter for that. And a cable. Oops. Okay. Alright, so to emulate a switch, I'm just going to pull one of these. Oh no, I have loose ones already. And I'm going to put it into... Sure, D17. And then I'll just kind of go tap it into another hole. So what we need to do here, as far as I can tell, we have a ZMK build environment. We have a board, so the Nice Nano V2. What we need to do here is define a shield, because this breadboard is effectively going to be a shield for the Nice Nano V2. So there's actually a thing, like, how do you make a shield on the ZMK documentation. So let me pull that up so we can all see it. Oh, I wish this breakpoint was a little wider. Okay. Actually, this is totally fine. Let's see. Let's get me some Safari going here. I don't know why it blinks like that. Oh, so that's not visible. There we go. I wish there was some sort of like, well, there probably is, some sort of like auto grid layout that I could put on here for OBS. It's like, okay, take this group of windows or group of display things or whatever elements and make it a grid. Whoops. What? Well, one thing that doesn't help is everything is a weird size. But, okay. So, we come over here to the board, shields, and key maps window. So it's not a self-contained keyboard because it has a board. Pro Micro compatible keyboard. So what we need here is create a directory, apps, app, board, shields, board name. Okay. Oops. That's not what I wanted. What is going on here? Huh? Oh. Somehow I accidentally got set to the wrong keyboard layout. Okay. So let's create a directory, ZMK boards. Let's call it breadboard. Bread kitchen. Basic shield and Discord. I kind of want to walk through everything just so that I know, yeah, so to learn it more. I don't need to have the shield actually defined in ZMK proper, correct? Like I can do everything in the, this is effectively going to be a user config. But it'll contain the board definition, or the shield definition too. Kind of like the Zapod repo. Or not the Zapod config. This config. Okay. So here I just need like, I need a bread kitchen dot map off. No, wait. Sorry, I'm messing this up. Okay. That's a board too. Okay, I am gonna cheat because I don't really know. I don't really quite understand what the structure of this repo should be, the initial structure. Because looking at the docs here, I'm assuming this app is in the ZMK directory, an actual ZMK repo itself. Okay, config boards, shields, Uno trio. Okay. So those are the files I need. Where did my terminal go? Config boards, shields. Okay, now we can go back to this, I think. kconfig.shield defines the top level kconfig value for the shield. I thought there was a how-to for this. This isn't what I was looking for. Have it on my iPad. 1 second. I think I just kind of went new keyboard shield. Okay. This is what I was looking for. This is what I had earlier. Okay. So we're not doing any of that because I have this set up with Docker. All this, environment variables. Yeah, no, it's fine. Maybe out of this, there will be like a... I'll make some documentation for how to... something. Development new shield. That's weird. And I refresh, and it loads the page. Computers. Why? Why? Whoever thought computers were a good idea? This is the thing I was looking for. Oh my god. Okay. That was... more frustrating than it should have been. Actually, I need this back again, so I need the kconfig.defconfig file. And okay, so we need config shield is bread kitchen. Oh no, that's the shield. Wait. Whoops. Oh my god. So there's something that's a little surprising. Emacs is the text editor I'm using. It does not have a mode, a native mode for this type of file. And I don't get it. I don't know why. Like, you would think of all the like neckbeard things that Emacs would have a mode for this, but it doesn't. Like, there's one, or there is one, but it's like super not good. Pro, micro, and we said D17. Okay, direct wire. So that's the overlay file. Okay. So yep. But I still want Pro Micro D, right? Or Pro Micro underscore Pro. Whoops. Oh, I see. So then this would go to active high. So in order to type with that, I would connect VCC to, or no, I would connect ground to that pin, right? Because what it does is it sets the pin to high, and then when it detects that the pin has current going through it or something like that. Okay. GPIO. Oh no, GPIO active low. Yep. Active low. type IO pull it high, active low, connect to ground. Okay. Oh. Whoops. All right. Okay. Don't need a matrix transform. When connected to ground, the pin will be pulled low. Okay. Cool. Nice. Yeah, this is the first time I've, other than when I made the blink, the light blink on this Raspberry Pi Pico last night. This is the first time I've ever done anything with microcontroller programming or anything. So I am very, very green at this. Okay, cool. So, write that. Then we go to key map. Include behaviors.dtsi. Include pt bindings / ZMK / keys.h / I haven't done a lot of programming on this keyboard with this layout, so it's still very not muscle memory yet. Make a lot of mistakes. Okay. So then this should just be, I define default layer, and there's just one key, so I can do like, why is it doing that? Bindings equal, and then APA. Yeah. Alright, well, let's give this a try here. So I need to docker compose run, but it's not Zaphod config. It's Oh. It's a V2. Yes, nice nano V2 underscore V2. And then dash D shield equals the hell did I call this? Bread kitchen. Oh. Node kscan 0 does not appear in GPIO map. At connector D. I wonder, should this just be kscan? Because that's what this one is. YOLO. Nope. Node kscan slash kscan. Okay, so it is this that it doesn't like, but I don't know why. Let's see. Yeah, I think I'll figure it out. I'll learn something anyways. Like I said, if all I get done today is getting so I can tap and make a a key work, I'll be very happy. Okay, so let's see. Let's check out. Let's develop main. No. Actually, we want... Oh, wait. I know what the problem is. I'm checked out in the wrong branch. So what I want is kitchen docker composify. Okay. I think. Because I'm guessing that fork/branch that I was working from didn't have nice nano. So let's just see if I screwed everything up. Nope. Okay, so let's do this again. Build. Okay. Child specifier for node kscan. Okay, so let me put it back to kscan 0. Alright, I'm gonna try one more thing here. Nope. Okay, kscan 0. But at least what we can do now is... You know, I wonder. So child specifier for node kscan 0 does not appear. A connector D, property GPIO map. Oh. Okay, that's interesting. So what I'm seeing here, so I just searched for GPIO map, and I see in all the boards, I see nice nano, NRF micro, etc. This Arduino Pro micro pins.dtsi. However, there's no nice nano v2. So I wonder, app boards, is there a nice, oh, there's not. So it just uses okay. So that's yeah, okay. There's so many layers of things going on here, and I'm trying to understand how they all piece together. I mean, maybe D17 is wrong? Oh, there's GPIO 17. Oh, wait. Yeah, there is no D17. I think that's what it is. Oops. Okay, so what I need to figure out is Pro Micro D. So what are those actual pins here? Whoops. Pro Micro A. Three. So I guess the labels on the pins on the back of this are just wrong? I don't know. But that looks like it got us past where we were. So that's a good sign. And I should put another pin in here for reset. So I can quickly reset the board. Actually, you know what? I wonder, can I do some fun stuff like I've got these extend a cable things. BLE device name is too long, max length 16. Okay. I stick this on a switch pin. Now it's not going to stay. Never mind. I was thinking about making a little reset switch for the board by using an actual switch, keyboard switch, but the pins don't, they're not big enough to stick into the header holes, apparently. And I don't feel like soldering it or something like that. Wait a minute. I gotta check the music real quick. Because I know this song. Huh. Is YouTube telling me I have copyrighted music? No. Weird. Switch to my other water. Okay, so we have a firmware. Let's copy this over. I think it's this one. Yeah. Let's see if that actually works. Okay, so if it works, this is connected to ground. Should type A. No. Oh. Yeah, it's plugged in. Although I wonder if it's not defaulting to USB. So let's enable debug. USB logging. I'm not going to do a pristine build because we've already built a lot of this. Well, I thought taking pristine out would make it a little faster, but I guess not. Oh well. Wow, I swear this is taking way longer than the previous one. But that might make sense because of enabling debugging. Well, no. So I'm sitting here thinking about why this isn't working. And I wonder if... Wait a minute. Actually, hang on. Maybe I did a stupid. Did I do a stupid? I did a stupid. Okay. This is the ground on the other side that it needs. I was looking at this, and it's face up, but this is face down, so I need to use the other columns. Okay, let's see if that fixes it. Durr. Okay, try not to hit VCC, which is right next to it. Okay, yeah, I have a functioning keyboard. It types A. Okay. Cool. But I still want the debug anyways because that's going to come in handy later. So let's do double tap reset. Okay. Get our firmware copied over. So we have USB debugging. Okay, only USB is ready. So let's see what happens here if I tap that. Okay, so that's saying it's really want to get... Okay, whatever. Cool. So it's working. Got that. Great. Now I have no idea what to do next. How to get this going. Other than, I guess, start looking at the pinouts and trying to get this wired up to the nice Nano. We do have a functioning keyboard with a nice Nano on the breadboard and all that fun stuff. So that's good. I kind of want to take and make a... I should get some like breadboard switches. But anyways. So actually what I'm going to do here is I'm going to... Hello, Maker Jake. That's not what I wanted. Okay, cool. So that exists on the internet. I'm not gonna set up builds or whatever, but I might. Well, okay. Okay, so, because I like to document things, especially if it's like, here's how to actually use this instead of it just being a bunch of files. Yeah. Should also make a license file. Someone once told me that you should always have a license in your GitHub repos because it makes it easier. Like, if someone looks at your GitHub repo and is like, oh, that looks really great. Oh, there's no license. I don't know if I can use this. Yada, yada, yada. Put a license in there, even if it's a public domain license or something like that. just because it makes it clear your intentions. And it makes it easier for other people to share code. And 90% of what, maybe not 90%, a lot of what I do coding is on GitHub nowadays is like configuring things. So like my QMK key map and my ZMK key maps and stuff like that. Like that's just configuration. I don't really see that as code, as something that's licensed or licensable, but I just go like, hey, it's just do whatever you want. I don't care. So. Okay, so that's good stuff. So I'm going to pull up. This is a Cirque keyboard or a touchpad, Cirque something or other. So let's get the spec sheets and stuff, resources, developer resources, documentation. I don't remember what exactly this is. So I'm going to look at my email at the order, but I'm not going to do that on stream. Oh, wait. Okay, so I am going to do it, but I'm not going to do it on stream. But if I pull up my order, if I pull up the product page here, okay, so it has datasheet right here. And this isn't the exact one that I have plugged in here, because I have a couple of other ones in the bucket here. The main difference is size and whether or not they have a top on them. And I guess the third one is AWOL. But they're all the same thing. They're just different size. So let's look at the data sheet. Interface specifications, communication specifications, mounting design, ESD test. Oh, interesting. So this looks to have inputs here for mouse buttons. Because this, you can wire this up such that it is a mouse in itself. Like it is a, I think a PS2 mouse functionally. So it has support for the buttons, for the mouse buttons, and probably scroll wheel, I'm guessing. But one cool thing is I don't need most of these buttons, or most of these pins. Probably just need SCL, SDA, ground, and 3.3. Okay, and so by default, it's I squared C. Oh wait, no, there is a resistor on that one. Okay, so this is, so it looks here like If there's a resistor on R1, it's configured for SPI, and if there isn't, then it's configured for I2C. But this one has a resistor here. Can't see it. But it's there, trust me. Position reporting. Maximum range. Evaluating the trackpad. Mounting design recommendations. Okay, cool. And if I remember correctly, the Nice Nano has 3.3 volt VCC. Yeah, voltage 3.3 volts. So I can take the... Okay, cool. It's not going to work, but it's going to maybe get powered up in just a moment. Hopefully I don't let the smoke out. So because I'm wiring things, I'm going to unplug stuff. I really should have put this closer, but I have longer... jumper wires. Okay. So VCC. Oh wait, I don't need that because I've got a bus along the side here. Okay. VCC to positive there. And then we'll connect these across here just to have... Yeah, now we won't. Screw it. That's not what I wanted. This is what I wanted. So got pin 1 through 12. So it goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So pin 1 is... So pin 12 is what I want to hook up to VCC. Which should be the bottom right one here. Hook that to VCC. And then 11 is ground. Okay. And then smoke out. Do we still have a functional keyboard? Yes. Okay, good. So that didn't let the smoke out. So that's good. Okay. So what I'm going to do here is I'm going to look for VDA. No. ECL. No. So there's no mention of it. How about OLED? How about SPI? No. I2C. I2C. Okay, so so this is the OLED display. Okay, these are all for displays. I don't know. So that's the pins. Okay, I think I'm getting somewhere. So, what I'm looking for is like, where's the code that defines all this stuff? Like what? So that's def config, ttsi. So this has SSD 1306. Ah! Damn it. There we go. Okay, we're getting started, or we're getting somewhere here. ZMK display status screen. It's weak, so that I can get overridden in other things. Whoops, I accidentally killed the music. Ah. Okay, so what I think maybe I want here, sharp memory display, shield. So I think what I want is a mouse shield. So I think I'm going to end up having to hack on Zephyr itself. Write a driver for this. But I have no idea. Oh wait, what is this? ADC click. No, it's an analog digital converter. ETH click. Ethernet controller. Yeah, this does I2C and SPI. But I think I'm going to use I2C because I think that's easier? Maybe? Like, I feel like I can probably just hack this somehow. Or, like, use this as a starting point. Alright, we're gonna go clone Zephyr. Why not? Zephyr project. Getting started guide. Install deps, not gonna bother with any of that. Install toolchain, not gonna bother with any of that. Wait, where do I get Zephyr? Okay, we're gonna do this the hard way, hard-ish way first. By docker run rm it hash. What? No such package G++ multi-lib. Maybe it's no, Bionic is 2004, right? Oh no, 2004 is Focal. Oh, it's in 1804, so it should be in 2004, I would think. There it is.
Can't you see what love and romance have done to me? I'm not the same.
Ah. That's a good idea, Jerry. I'm sorry, I screwed that up again, didn't I? Jerry or Gary? All right, Steve. Ugh, why? Okay, so let's make version Python 3 version etc. What? Okay, how does that magic work? Because West is a general purpose build tool, right? It's not specific to Zephyr? Huh. Okay. Today I learned. Wow. This sample program can confuse your I2C bus, cause data loss, and is known to corrupt the Atmel blah 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 EEPROM found on many IBM ThinkPad laptops. Well. But this does give me somewhere to look at here. Now I'm really should have done this in a Docker Compose with volumes and stuff so that I don't lose all this stuff, but oh well. There we go. I mean, I feel like I2C is fairly low level. Like, if you're working at that level, like, you're at the whims of whatever rando hardware you're plugging into things, so. Sample. Oh, wow. Okay. So maybe I should start, instead of trying to hack on ZMK proper, hack on Zephyr a little bit, and then work my way back. Because the nice Nano is basically an NRF whatever chip with the pins broken out. So I should be able to do it manually. Okay, well there's an SPI sample. And there's an I2C sample. Okay. Alright, so yeah, I'm going to undo all of that, basically, that I just did. Zephyr... Let's make Zephyr... Fun times. Whoops. What? Okay. So Zephyr build. Okay, so okay. I swear I have a fast internet connection. We're downloading like a couple of gigs right here. You know what? I actually might switch to using this because this has an OLED display built in. Breaks out the pins I want, I think, anyways. I don't know. We'll see. So what this is the cduino Xiao. The thing the Hummingbird uses as a controller, and this is like its companion development board that comes with it, or that you can buy with it. It's got a reset button, it's got a power switch, all that good stuff. And it just drops right on here, and then you've got all these pins broken out to do stuff with, and you've got an OLED display already there. So, it might be worth doing. We'll see. I'm just playing around with this stuff at this point. Like, I have a direction that I'm heading in, and I'm trying to, as long as I don't get stuck and I'm like, well, I have no idea where to go from here, I think I'll be fine. And so far, I have a direction. You know, I'm going to build Zephyr. I'm going to try to run a stock Zephyr Hello World app on the controller, maybe? I don't really know. Or get it to compile. Look at some of the other drivers that are made. There's the samples. Oh. It's still downloading Docker containers. But yeah, just try to figure out those things and go from there. And probably a lot of talking to Pete. But, Pete's not around, so I'm trying to move forward without his assistance. Because unlike some people, I think Pete has a day job. I just stream on the internet and build keyboards. So one thing I'm not going to try to do out of the gate is get this working on the Zephyr. I want to get it something going with the breadboard, whatever, just for reduced complexity. Get it so I can like read the data that's coming out of this and start understanding what I need to do with it or whatever. Then at some point go like, okay, now how do I wire this into here? And then from there, it'd probably be something like, how do I build a PCB that this can attach to with all the components it needs to be able to plop right in here? But who knows? I'm not sure if you can get these without the ribbon headers. Because those add a lot of thickness. I imagine you can. Okay, so now I should be able to Docker run, or no, Docker compose run shell bash. What? 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 I don't even know what's on. I don't know what's. Okay, I don't like that image. I don't think. Warning, no resource, but it's right there. Oops. I never remember the Docker file syntax. That's not helpful. What? See you, Gary, Jerry, Steve. There we go. Well, I didn't realize that this was all, like, behind everything. I'm such a terrible host. No wonder nobody's watching. I can't see anything I'm doing. Oh dear. Hmm. All right, so that's done. The main reason I'm doing this as a Docker Compose setup is kind of for repeatability, but mostly so that I have a Docker container that I can exit out of and enter back into easily. You know, Docker Compose run shell bash, and it drops me into the shell for that environment with the volumes mounted that I want and all that good stuff. And I don't have to like docker run -it -rm with, you know, mounting the volumes manually and doing all that stuff and creating. This is just way easier. Way easier. I wonder what it says on Mac OS to do the flashing stuff. Zephyr SDK is not available on Mac OS. Never mind. Ooh. Okay. Yes. So I am going to switch to the cduino because Zephyr directly supports the cduino as a -B here. So, perfect. Need another USB thing. Well, it's got some firmware on there because it's got a couple of blinking lights. One next to the USB port. That's hard to see. And then the other one next to the power switch. Or whatever on-off switch that thing is. Okay, so... CD... Zephyr project, Zephyr West build -T auto -E. Not auto, or audio. There. Okay, I'm running into a wall here. Rerun CMake with a different source directory. What does that mean? There we go. Oh, lib64 LD Linux. So it can't find a shared library file. This one. So I need to install that. Oh, that's user. Huh. Okay. I think I'm gonna back up one step. Because if I do... So this is, I am in a functioning Zephyr build directory here. So if I do, say, maker Zephyr project, Zephyr init, Zephyr project, or no. So what I mean by this Docker environment that I'm in is the one that I use for building ZMK, but it already has a fully functioning Zephyr SDK and everything in there. So like, I'm having trouble setting up the Zephyr SDK on this other Docker container, probably because something I'm running an M1 Mac and maybe the Ubuntu image is an ARM image. I don't know exactly what's going on, but what I do know is something is fishy, something is a little weird, and I want to get past that and maybe come back to it if I feel like it, if I can. So that means if I can go in here, do this, do a West update here, and build this firmware for the cduino, then I don't really care that it's ZMK's dev environment, because it's just their Docker image to set up a Zephyr SDK environment. If any of that makes sense. Because then what I can do is just come in here and change this Docker Compose to use the ZMK build, call it a day. Because if we look at this one, this is doing ZMK dev ARM. So, and it's building from that Docker file. So yeah, we'll see. Okay, cd Zephyr project, West updates. So I think at this point, my goal is to get this West build that I was trying to do over here to build the Blinky for the cduino, flash it onto here, and then call it a day. Does this have ZMK style? Yes, okay. So if I double tap the reset button over here, it pops up a amount of volume on my desktop that I can copy the files to. Okay, cool. This has been amazingly informative for me. Starting to understand some of the moving parts here. Kind of going back to the basics and just working on Zephyr instead of trying to jump straight into ZMK to do all this stuff, I think is going to be very helpful, especially because I think that most of the work I need to do for this is actually in Zephyr. And then I get to learn about Zephyr, which is cool because it seems like a really cool piece of software. I get to play around with microcontrollers and just, yeah, I don't know. I'm having fun. It's making me work my brain quite a bit, and that's a good thing. That's a really good thing. But once I get if I get that working, I'm gonna call it. If I don't get that working, I'm probably gonna like try flail a couple more times and then call it a stream. And then come back to this in tomorrow maybe. Talk to Pete a little bit later about my progress. Yeah, see, there's like a very basic device tree mode for Emacs, but it's like ridiculously, like, that's the whole thing, and I just don't know. I should probably try it. Because, I mean, device tree isn't a very complex syntax, I don't think. Why is this not scrolling? No. For a second I was like, my internet just go down because my Wi-Fi indicator is crossed off, but this is hardwired, so. But something isn't right here. Oh, now I'm getting beach balls. This is fun. Okay, I want to download linked file. We'll open this in preview. Oh, this is beautiful. Okay. I want circuit Python I2C. Hey, it's done. Okay. So now if we do Zephyr, so we can do, what is it? This. Maybe? Nope. Okay. Following configuration files were considered but not accepted. Not. Can I find a configuration file for package Zephyr SDK? It's compatible with requested version 0.13. Okay. Okay, so this is an issue with Zephyr SDK version because something wants 0.1.3. I'm guessing that's a lot of stuff in here. Minimum required version 0.13. Okay. My brain is shot. I'm gonna call it a day. This has been a hell of a lot of fun. Hell of a lot of fun. I got a hand-wired effectively, or like I got my kitchen breadboard keyboard working. It works. It has firmware that builds. I plugged this in and it didn't let the smoke out. I made some progress in understanding what maybe I need to do for next to get a driver or something for this. I have a couple of notes here on like things to explore. So Jerry had the wonderful idea of like look for an example that lists the devices on the I2C bus. Great, I can do that. I found a Circuit Python example while I was waiting for all the build stuff to go. So in theory, I should be able to do that on the Arduino, or sorry, on the Raspberry Pico. because that already has CircuitPython and stuff ready. I can just copy paste this thing, and like in theory this should just show up, and that'll at least like validate that I've got it wired properly or something. Maybe I can play around with like just understand what I'm working with I2C over here in something that's a little more familiar. I did not manage to get the firmware compiled for this, for the cduino, but I think that's at this point, it's a version compatibility issue, because the Zephyr SDK that's installed in the Docker container that I'm using from ZMK is 0.12.4, and the upstream code that West init and West update pulled down once 1.3. So I have to figure that out. So at this point, I'm just basically fighting with Zephyr build environment. So I will probably do that off stream, because that stuff's boring and like takes forever. Like I just sat here for like 20 minutes waiting for that to compile and stuff. So I'm gonna just try to not do that on stream so that y'all don't completely fall asleep on me. Hopefully tomorrow, or by tomorrow, I'll have that figured out. I will have a functioning thing that I can flash to here and play with, and I'll mess around with getting this going on the Raspberry Pi, or the Raspberry Pico, and see if I can't start kind of playing around with what the hell is even getting sent down the wire here, and how do I interface with it. Anyways, this has been great. I'm gonna call it a stream though, because it's been it's a solid 3 hours here, and yeah, I want to go do some other things, and anyways, no excuses. I will hopefully see y'all tomorrow. Have a great day. Bye.